Okay, welcome back for another video lecture for Math 1316, Trigonometry. And this video lecture will be covering section 4.2, where we discuss the idea of horizontal translations and vertical translations. In other words, phase shifts and vertical shifts for trigonometric functions, specifically sine and cosine. So in the last video, we discussed the general form for the trigonometric functions, and that is that we have a followed by one of the six trig functions, and then we have b distributed into x minus c, and then all at the very end, we're going to add d or subtract d on the end as our vertical shift. And I talked about a lot of the concepts that are actually in 4.2 during that video, so this one will prove to be quite short. I just wanted to work you through a quick example and some understanding about the way that B, the period, works, and the way that C, the phase shift, works. Vertical shift is very, very easy. Sorry, the cat's getting in the way. Vertical shift is very easy. Whatever the vertical shift says, that's how far the midline of the trig function has been moved up or down. So it's really quite easy. Um, A, again, we recall, that's the amplitude. B controls the period. C controls the phase shift. So here at the bottom of this Desmos screen, I have put an example in to our input line here. This is 2 cosine of 2x minus pi over 2 plus 1. And the goal here is to determine what what the period of this thing is and what the phase shift of this thing is. So commonly students will make mistakes when answering these types of questions because they'll say that the phase shift is pi over 2 because they look at it and it's in the plus or minus after the x within the argument of the trigonometric function. Incidentally, the argument, again, as a refresher, that's the inside portion of the trig function. So cosine of the argument is what we're trying to graph right here. So a lot of students will look at this and they'll say, okay, well, it's pi over 2 because they'll see that that's in the position of C, and they'll fail to notice a very subtle difference between our general form up in the top line of this Desmos screen and the question that we've been given in the bottom line of this Desmos screen. So if you look at the top line of this Desmos screen, what you'll notice is that the B value, which controls the period, must be distributed over x minus c. And in the bottom line of this Desmos screen, we see that we have 2x minus pi over 2. In other words, we don't have a value in front of this thing being distributed over x minus c. Now C is the phase shift, but it's obscured here because remember that this value of B has to be distributed over x minus c. So what I actually have here is 2x minus pi over 2, where pi over 2 is equal to b times c. So what I need to do is factor this argument and pull a common term out of it so that I have this nice distributive action of b into x minus c. So we notice that this is in fact 2, oh, I got my caps lock on, 2 cosine of 2 into x minus something, and then at the very, very end, I'm supposed to have plus 1. So when we figure out what this something is, I need a value that when I distribute 2 into it will equal pi over 2. So pi over 4 happens to be that value. And you see right now that the original purple line and the red line are the exact same thing when we look at that. So when we're asked for things like the amplitude, that's saying what is the A value? The A value in this case is 2. The B value is this number that is distributed over x minus c in the argument. So we have 2 for our B value. The C value is just the number that is being subtracted from x within the argument. So we want that to be pi over 4. Give me just a second. I want to make sure that we're in the right step here because I forget what I have this set up. Step is pi over 12. Okay. So that means pi over 1, 2, 3. That's pi over 12 right there. And then the last thing is we have this d value on the end, which is the vertical shift, and it moves it up, and you see that everything is all kind of overlapping now. So that this purple function, that's the original thing. All right, and then we have this red function, which is just kind of overlaying it at this point, so we can't really actually see it. Okay, but if we turn it off, we can see it. There it is. They are both the exact same thing. Okay, so the point here is when we look at phase shift, we always want to be wary of numbers that are multiplying the x term within the argument because those mean that our phase shift is not just an obvious thing. So if we wanted to graph the sine of x plus 3 pi over 4, just keep in mind that the phase shift, it's supposed to say x minus c, so we know the phase shift is negative or it's going to the left. And the phase shift in this case will just be 3 pi over 4 because there is no value in front of the x. We don't have to do that factoring like we had to do in this previous example. And so we can simply state what the phase shift is. Just remember that the phase shift, much like horizontal translations in college algebra, if we have minus something, it means phase shift to the right. And if we have plus something, it means phase shift to the left. So it's the opposite of what you want to say about it. All right, so here we have another example. This was cosine of x minus pi over 3. We can see very clearly that the phase shift is pi over 3 to the right. And this one also has the added little thing on it of we have a different amplitude. We have a negative 2 in front of it, so the amplitude is 2. And also this has been reflected across the x-axis. But if we look at the example in number 3 here, then we have some slightly different things that we have to worry about here. Let's go over and put this particular expression into Desmos. So what we have on this group of classroom notes is 3 halves cosine 2x minus pi. Okay, so that's 3 halves cosine of 2x minus pi. All right, so this is what this thing is supposed to look like. I'm going to reset our graph so that we can see what the phase shift and everything is supposed to be. All right, so there's your B value, there's your A value, there's your D value. All right, so the purple line is what we're supposed to get by graphing this thing. Now, first of all, we should notice that our amplitude, if I turn on the original red line, this is just a standard cosine of x function. The amplitude is 3 halves, which is 1.5. So I need to adjust the A value so that the peaks and troughs are in the correct place. All right, well, next we notice that the B value is, we don't have this nice B distributed over x minus c. We just have one single thing in the argument, 2x minus pi. So I need to factor a 2 out of the expression 2x minus pi. What that gives me is that b is equal to 2, so that part should be pretty obvious. But then we have this phase shift, and this phase shift is minus pi normally, but remember when we factor this thing out, what we're actually looking for is 3 halves times the cosine of 2 distributed into x minus something that when multiplied by 2 will give me pi. Well, pi over 2, when we multiply that, that will give me the correct expression on the inside so that you see this blue line and this purple line, they are in the same place now. So that means that the C value of the phase shift actually needs to be, pi over 2, which is 1, 2, 3, 4, 5, 6 clicks on C. So this is the decimal representation of pi over 2. It's 1.57, and now you see that all of our lines match up and we have the correct graph. So when we want to respond in Pearson with what is the amplitude, you see the amplitude is very plain. We can just look at the original expression, remembering this purple line, this thing right here, this is what was given to us. So this purple line, we have the phase shift, the amplitude, is just 3 over 2, which is the very first number. We have the B value. We can even see that without factoring it out. It's just 2 is the number in front of x. But in order to calculate phase shift, because the general form requires this b to be distributed into x minus c, what we need to do is take the b value that we have times c equal to whatever the value right here where the c should be is. So what we're doing is we're saying 2c equals pi, and so that means that c is equal to pi over 2, and that's what we plugged in here. That's our phase shift. Okay, so anytime we have these translations here, just be careful. Phase shift is really the only thing in trig graphing that's really difficult. The rest of these notes are all about vertical translations, and just a reminder of what these things are. All that a vertical translation is a movement of the graph up or down. So if it says +6, all right, well then the midline has been shifted up to y equals to 6. And if it says -4, then the midline has been shifted down to y equals -4. So vertical shifts behave very much the same way they did in college algebra. The only thing we really need to take extra special care of is the phase shift, because it does not necessarily do exactly what it says in the expression, and you've seen a few examples of that here. So if you understand that, and you have watched the previous video lecture, which goes into a little bit more detail about graphing, then you understand 4.2.